Hello everybody, I'm Dan. Welcome to my Java tutorial series. Throughout my tutorials I will teach you Java using just Notepad and the command prompt. The order in which my tutorials are organized on both my website at javacjava.com and my YouTube playlist is designed to maximize learning by building on concepts from prior tutorials. This tutorial is about the long class. I'm going to open up my web browser to my website, javacjava.com, and select Begin. I'm going to scroll all the way down here to the long class. The long class is a wrapper class that wraps a value of primitive long data type into an object. Now I highly recommend watching both my primitive wrapper classes tutorial and my Autoboxing tutorial before continuing with this tutorial. You'll need to understand certain concepts from both of them in order to fully comprehend the material in this tutorial. It is important to note that the long class is immutable. Okay, the fields are constants. The long class contains a total of 5 class variables that are essentially constants: bytes, max value, min value, size, and type. I will show examples of how to access these members, but the type is beyond the scope of this tutorial series thus far, so no go. The long class does not have a no argument constructor. That's critical for being immutable, by the way. But the class has 2 public constructors. One takes a long value, primitive long value, the other takes a string object. Methods. The long class has over 3 dozen methods, so I won't list all of them here. I will demonstrate how to use some of the methods in the example code. A few of the methods will require their own separate tutorials. Many of the methods in the long class are prone to data loss if the value of the long object is outside of the maximum and minimum range of the data types returned from certain methods. So in other words, if you have just a huge value that's, say for example, larger than an integer, well, when you convert it back to, say, an integer, it's going to lose data. If you convert that value into a short, it's going to lose data. If you convert that value into a byte, it's definitely going to lose a lot of data. So that's basically what I'm saying on that. So let's come down here. I'm going to just simply click, left click, hold down my mouse button, and use the down arrow on my keyboard to control the scrolling here. And right down to there, and then hit Control C on the keyboard, and then, or right click and select copy to highlight all that stuff there. Okay, and I'm going to move my browser off screen. I've got a shortcut to the command prompt on my desktop, but if you don't, you can create one very quick by right clicking, new, shortcut, CMD, next, and finish. Okay, let's go open that up, type in Java C, which is the Java compiler, press enter. You should see all this stuff scroll by. However, if you get an error message, watch my tutorial on installing the Java Development Kit. You're going to want to make sure you get that installed and configured properly before continuing. CD space backslash, CD is short for change directory, and backslash tells it to go to the root. I'm going to make a directory here called Java using the MD command. I already have it, but if you don't, it'll create it for you. I'm going to change directories to the Java folder. I'm going to make another directory here, and I'm just going to call this one long class. Change directories to the long class folder. And notepad longclass.java. Okay, paste all this stuff in here, save it out, and the first thing I'm actually going to do is just go ahead and run this, and then we'll take this code statement by statement here. Java C, and let's clear our screen. Java to want to invoke the long class. All right, scroll all the way back up to the top here. Alright, so the first thing we've got here is the class variables, or constants, or you can call them fields, whatever your preference is there. So, the number of bytes in a long, there's 8 bytes in a long, right? Number of bits in a long, of course there's 64, and basically we're accessing directly, because these are static, class variables here, so long.bytes and long.size, and so 64 or 8 bits in a byte, right? 8 times 8, 64. The math works out great on that. And then long.max value and long.min value here. So that's the maximum value of a long right there. That's the minimum value of a long right there. Okay, so that's the range there. All right, so the next thing is the constructors. The constructors are interesting there. So as you can see, we can just do a 41 here, right? Now, even though that's going to take a primitive long type construct parameter there, I wanted to show you that there's just a little bit of like some inconsistencies, right? on what you can pass into some of these, what you could basically pass in for the arguments there. Now you'll notice here I don't have an L, right? You might not have noticed that, but let's say for example we have the L or we don't have the L. I chose not to put the L in here just because, obviously you can see it compiled there, and I've got, this I1 reference variable of long type and setting that equal to a new instance of a long object containing the value of 41. Now that was a primitive long type parameter, right? So to be technically correct, I should have put the L on there, but I'm just kind of showing you you don't necessarily have to in the constructor. That's a completely different story on all the methods there too. Some do, some don't. So just wanted to show you that. But so anyway, I1 equals 41, and then here's the other constructor that takes a string type argument, right? And that's equal to 41 too as well. So this first parameter up here could take either like this is an integer literal, or it can take like a long literal, right? By putting the L on there. As a matter of fact, I'll just go ahead and save that out, show you there. So I'm gonna do some other manipulations down here too as well. So for the common methods, the first thing I'm doing is I'm autoboxing a temp reference variable for examples, right, of long type, right? And the autobox will take this 0L here, right, and turn that into a instance of a long object containing the value of 0. Same thing with temp2. Now here's what I'm talking about with, like, let's say for example with autoboxing. If I leave off that L, I'm going to go ahead and save this. This won't even compile anymore because the autoboxing, that particular feature requires that as well. So I'm going to clear the screen here, Java C. I'm going to go ahead and compile that and see you get incompatible types. Int cannot be converted to long. And that's in the autoboxing right there. So you have to make sure that you're going to keep your L on there indicating that this is a long. Now, one of the things that is difficult to explain to someone who's learning the language is why you have to put this L after there and what it really signifies. And I'm going to show you what the L really is. It's nothing more than doing a cast. Okay, so we could cast this 0 as a long type, and that'll be okay too, right? So essentially, there is no difference between let's see, pull this off right here, right? There is no difference between 0L and casting 0 as a long. It essentially does the same thing, right? Both of them are going to work just fine, right? And so, that's essentially that. So hopefully that's one light bulb going off in your head and you're like, oh, okay, that now makes sense on why I have to have an L after there too as well. And same thing with like a D for double or an F for float. Those are no different than if you were casting them as a float or casting them as a double there. So that is that. I'm just going to go ahead and strip that out of there. We don't really need that in there. I've probably spent way too much time already talking just about something simple like that. But anyway, let's go ahead and compile this, rerun it. Come back up to where we need to be here. All right, so now we're going to start talking about a lot of the methods here. Okay, so the first one, byte val, and it returns the value as a byte, and it may lose data if outside byte bounds, right? So first I'm autoboxing just the number 41, and remember I have to include the L here, right? And I'm saying byte B equals temp.byte value, right? And then displaying that to the console here. Right up here, got byte B equals 41. Now, if I say temp and I autobox 21,999L to the temp instance there, basically we're going to end up losing data when I take B and assign it byte val, right? So right here, byte B, lost data. -17 is what that turned into. So that's what I was talking about. If you have a value that's outside of the range of the type that you're working with, in other words, primitive type, its value is like -128 to +127. Anything outside of that is going to lose data. Okay. Now the compare is the next one here, and you can pass in two parameters here, long x and long y, and it'll return back an int data type, right? And the reason why it returns back an int data type is basically it returns 0 if they're equal. If x is less than y, then it returns -1. If x is greater than y, then it returns 1. Now this particular one, compare here, it works exactly the same way as the integer class. However, it does not work that way in both the byte and the short class. The byte and the short class, it'll actually return the difference between the two numbers that it's comparing. Same thing with the next CompareTo thing there. So that's one thing important to keep in mind, is that you don't always have consistency in the way these methods work across even related classes like wrapper classes. So just so you know on that. So compare 3636 equals 0, 3040, right? This is less than that, so that's going to return back a -1. This is greater than that, so that's going to return a 1. Okay, so that's how that works. Let's scroll up here on the CompareTo. CompareTo is, and by the way, this was static, so that's why we could directly call this. CompareTo is not static, so we have to run this off of basically an instance there. So invoke that off of an instance. So the CompareTo takes a long parameter, and that's a you'll notice that's like a long object type parameter there. And Autoboxing will actually go ahead and if we wanted to autobox something, it would go ahead and do that and take care of that for us too. But I'm just going to use the long parameters. So compares the long parameter against the current object. 0 if equal, current object is less than parameter, -1. Current object is greater than parameter than 1. So I'm setting temp to 35L, temp2, autoboxing that to 35L. So 35, 35, 0, right? CompareTo, then down here I'm changing temp2 to 40L. And then 35 and 40, -1. And then down here, I'm changing it to 30L, right? And 35 and 31. So that's how the CompareTo works on that. Okay, let's talk about the decode next here. So the decode takes in a string parameter, right? And returns back a long object instance, okay? So returns a long value from a string. And this should actually be uppercase L here. So the string parameter can be decimal, hexadecimal, or octal, right? And basically, decimal system base 10 can have a plus, minus, and this, or negative here, right? A hexadecimal has to have this prefix of 0x, and the x can be both upper or lowercase, or a pound for the hexadecimal. Octal has to have a leading 0 in front of it there. So you can see, decoding the string, right? We're passing in string parameters here on this, of -43, 43, -43, 43, right? 0xFF, which is hexadecimal, essentially equal to decimal 255. Pound FF, decimal 255. And octal 0104 is equal to 68. So that's how the decode works there. And there's a lot of interesting stuff where, like the methods are very similar, where they'll take string parameters, but what their return type is massively different. Like you might get something that's anyway, I'll show you here on some of these things. Double value. Double value is fairly simple. It simply returns a primitive double from the current object, right? So here I'm setting temp equal to this massive value L, right? And so that's all autoboxing will put it into a long. And then I'm saying primitive double D equals temp.double value, and then displaying that to the console, right? So for some reason when you display it to the console, it likes to put in scientific notation, 1 followed by all those zeros, and then E indicating exponent or exponential 12, right? Basically move the decimal point over 12 and you get your whole entire real deal number here, which is what we had right here, right? Okay, so that's fairly simple there. Now equals, no, I'm not doing a separate tutorial on that one. I don't want to have that left in there. Let's save that. Okay, so here I'm autoboxing temp equal to that, right? And There's some interesting thing about the equals here, right? I'm just going to go ahead and show you what that looks like. I'm going to scroll up here on this. Scroll down to get that up actually, but anyway. So in the first one here, remember the value of temp is basically this right here. So if I say invoke the temp and then I invoke the equals method here and I pass it the same thing, 933355L, right? That is equal to true. And then you know now that the L is essentially the same thing as casting it, right? 933355, right? That is equal to true as well. Now if I just put this in there as 9833355, which is an integer literal, all these are integer literals too as well, unless you put on the L, which basically typecasts this stuff too. But if I just pass in an integer literal like this, I'm not going to get an error message or anything like that. What I am going to get is I'm going to get equals false, right? So that's kind of what I was talking about up there in the constructors there, where it's not really necessarily consistent, right? Where I can pass in, basically 41 on this, right? And that will work just fine. Go ahead and compile that and run it again. See, I1 equals 41, right? But then coming down here to the, where are we? Where's the equals? Almost there to equals, right? Passing in a integer literal there will cause this to fail because it's not the same data type, even though that number will fit into a long, right? No problem there. But if we don't actually specifically have that L on the end of it like this, it's going to return false. That's something to keep in mind there, that you are going to have little inconsistencies across this sort of stuff there. So, okay, let's talk about the float value method here. Returns a primitive float from the current object, may lose data if outside bounds. It's kind of obvious there what I did with the byte up there and so on and so forth there, so I won't show you when it's out of bounds. But a float will hold 1,000,000 there, and we'll just display that to the console there. Simple conversion on that, float f equals temp.float value, 1,000,000.0, right? Okay, the next one here is GetLong, right? Now this one deserves its own separate tutorial, and I did the same thing for the integer class. Watch the Java Gotcha episode 2. GetLong will not do what you might expect. Now episode 2 is about the integer, getInteger method, right? Which is essentially, they do the exact same thing. So the GetLong basically does the exact same thing as the getInteger there. One just returns a long value, or a long object, the other returns an integer object. But watch that one there. It rather than doing a completely separate tutorial of a long one, it's just the same essentially there. But it definitely deserves its own tutorial. So next thing I want to talk about is hash code here, right? Hash code, there's definitely a potential for data loss, but hash code returns the hash code for the current long object. And it basically returns the primitive int value represented by this long object, which is essentially the same thing. So you notice temp is still equal to 1,000,000 long up here, right? So when hash code at that point in time will just return back 1,000,000, right? Okay. Now there's another overload of the hash code down here where it takes a long value, and this one's static, so we can directly invoke it off of the long class there, and it returns back an int type, right? So there's possible data loss on this one here. So essentially returns the, I should say same thing, as the parameter, but I'm not really sure the purpose of this method here. So I'm going to show you the data loss here. So first, if we do I don't know, whatever this is, 300 billion, right, which exceeds the value of an integer, that will return back as negative 64, or what, 647,710,651, whatever, right? So we overflowed it there. We had data loss on that when we did the hash code there. And then long hash code with 300 million will return back 300 million because that's within the bounds of the int data type. Why hash code returns back an int primitive type, I don't know. Doesn't Can't really come up with any reason for that. Maybe hash codes just can't exceed that particular value. But it's the only one I know in here that you know, you're passing it a long value and you're actually getting an int value back, but it doesn't really, I just don't understand the reason why, you know. Obviously, if you're in the next one down here, int value, right, you're returning an int primitive value from the current object, and that may lose data if outside the byte bounds, right? But that one makes sense because the name of the method is actually int value, so, but anyway, just something to be aware of on that. So, in the next one there, int I equals 1 million, so that's all good there. Long value returns a long primitive value from the current object, right? So, so basically that just will convert the long, the object state of that whatever long instance you've got going into a primitive value there, right? So long var equals 1 million there. Okay, now we're going to get down to the ParseLong stuff there. And so basically this one here, ParseLong, there's two overloaded versions of it here. So we've got the string s, so it returns a long primitive value from the string parameter. Right, so we pass in a string, we get back a primitive long. So if I wanted to parse, say, 11,987 as a string, right, and that'll return back to a long primitive type, just display that to the console, 11,987. And then here's the overloaded method, string s and long radix. So this returns a long primitive value from the string parameter, and the radix parameter is essentially what base numbering system to use. So so long primitive type parse2 equals long.parselong, passing in the string parameter of negative 11,567, and for the second parameter, the radix. Actually, you know what? The radix is actually an int. I don't know why. Got a lot of typos in this one here, but this is the int is a radix there. But so that is a base 10 numbering system, so that'll return back negative 11,567. In the next one here, if we wanted to do a base 8, which is octal, right, passing in 027, that'll essentially translate into decimal 23, right? And then the next one here, which is 16, which is hexadecimal, if I do a negative FF, that'll translate into negative 255. Okay, then they have some very similar ones here called parse unsigned long and parse unsigned long, with two parameters. One's a string, there's a string in the radix. So it's very similar to the other one, only you can't do these negative values in here, right? You can only pass it positive values in the string, or else you're going to get an exception there. So let me move the iParse 5, 6, 7, and 8 up there. Okay, so, and of course it returns a primitive long data type here. So 2001, that'll basically return right back to 2001. And then the radix here, if I do string literal 75 base 10, that'll be 75. If I do an octal literal 011, that will be essentially equivalent to a decimal 9, right? Passing it the 8. And if I pass it 16 for hexadecimal and I pass it AC, and you'll notice for hexadecimal, the upper and lower cases don't even matter. That's why I did that. But the AC hex into decimal is basically 172. Okay, remainder unsigned. Basically, this is essentially what the modulus operator does there. You pass it a dividend and a divisor, right? And it basically says, okay, like right here, 15 and 6. How many times does 6 go into 15? Well, it goes in twice, and then it has a remainder of 3, right? 6 times 2 is 12, and there's 3 left over. So that one will essentially just return back 3. Not much of a point to this particular method there. It just seems to me like it'd be easier to just use the modulus, especially since we're just dealing with primitive parameters, and it's returning a primitive data type there. But anyway, that is, or no, actually, let me check the documentation on that. Hold on just a second. I'm not sure if I just did an error when I typed this out, because I'm sitting there going, why that? It just seems so pointless. I'm going to come out here and just go to, I'm just going to type in GetLong class just to verify that there real quick there. Come up here and go to the 8 remainder. Remainder unsigned. Yep, sure enough, that is a long, and it takes longs. Okay, cool. Just wanted to confirm that I was doing it right there. Don't want to teach you guys anything that's knowingly wrong, right? So I'm not saying that I'm perfect and know everything. I probably screwed up some things in these tutorials, who knows, but anyway, try to do my best to make stuff accurate there. Then the next one here is reverse, right? So reverse is kind of deceptive. It does not return, like say for example 4321 from 1234, right? It returns the long value by reversing the order of the bits in the 2's complement representation. Now don't worry about this method. I haven't done a tutorial on the 2's complement yet. I probably will in the future, but maybe not. I'm not entirely sure. So if we just invoke the reverse method, we can directly do this because it's static, right? And long.reverse and pass it the number 1. It's essentially going to come up with this value right here, right? Which if we come all the way back up to the top, you'll notice you notice maybe the similarities here between the minimum value of the long here. But anyway, I'm just kind of giving you a little teaser on, a little hint on what that actually really does there. So anyway, but don't worry about that. We're just going to move on. Short value returns a short primitive value from the current object, possible data loss. Here I'm just autoboxing 10,000L into the temp variable and reference variable, and actually technically the object instance that the temp variable is pointing to, but it's neither here nor there. So short S1, temp.short value, S1 equals 10,000. Fairly simple on that. Now the binary string, the 2 hex string, and the octal string, those are all pretty cool there. So we're passing in a primitive long parameter, right? And these are static, and it's going to return it as a string, right? So in each one of these, I'm just going to pass in 255, 255, and 255 there, right? And so long to binary string 255 shows you all 8 bits are set to 1 for an entire byte. So that's that. That's always cool to see if you really wanted to see binary, how something's represented in binary by passing it in a long. So, and then hex 255, FF, and then octal 255, 377. Okay. I'm getting close to the end here, so there we go. Okay, so toString returns a string object from the current value. Temp, of course, autoboxing 10,000L into the temp. And then string TS equals temp.toString, displaying that out there. TS equals 10,000. And now toString has basically 3 different versions of the method, 3 overloads per se. And now we can pass in a long primitive type and return a string object from that. So, and of course it's static. So now we can just simply say long.toString 45, string TS1, assign it to that, and display that out, 45. Then the other overloaded version of it here takes a primitive long parameter and the int radix, right? Of course the radix is what base numbering system to use. So here, all I'm doing is just passing in the number 255, and then 10, and then hexadecimal, and then octal. 255, FF, 377. Now you'll notice up here, right, this is FF 377. So, you know, that's to the hex string, to the octal string. Kind of almost the inverse of what the other ones are doing there, where we can pass in, you know, that, so. And then last but not least is the value of here, right? So, and once again, there's 3 overloaded versions of that, flavors of the value of overloaded methods. So the first one takes in a primitive long type, and they all return back a long object, right? So, and they're all static, so I can say long value of, for example, like 918. Okay? Now, you might notice this little inconsistency here, and I'm sure hoping you do, because it takes a long type here, and guess what? What do you think this is going to display? Do you think it's going to display 918? Absolutely. So there's a little inconsistency right there where you can pass it in an integer literal instead of actually specifying the L, right? Now you remember with the equals, if we didn't have the L on there, it's not going to be equal to it. So that's just something to consider there. And oftentimes you won't find that in the documentation for the API there, so I highly recommend just keep that in the back of your mind. It's one of the things that I don't know where I picked up and started doing that, but I'll actually try it out both ways, especially if I'm dealing with stuff like that there, you know, because you could get undesirable results, but just to make you aware of that there. So that did work on this particular one, passing in a integer literal, whereas, you know, I'm just going to scroll up there if you don't remember the equals thing that I'm talking about right here, right? Whereas if we pass in this up here and the equals up here, it'll say false, whereas when we put the L on there, it'll go ahead and display true, right? See that? True there, false there. Okay, so just little inconsistencies to think about here, and if you're thinking, oh wow, what about all these other wrapper classes? Well, each wrapper class has its own kind of nuances there, and that more applies to the long wrapper class. You won't run into that in the integer wrapper class because, of course, by default, when you have just something being passed as a parameter and you've got it as a literal like this, by default it is a integer literal anyway. So that is that. The next one here, let's scroll down here. For value of, takes a string, right, and returns back a long object type. So I got 8675309, and that's just converting that out to there and displaying that out, right? 8675309. And then the last one down here takes a string value and then the radix again and returns a long object instance there. So here I've got 25510, FF16, and 011. And 8, basically the octal, the hexadecimal, and the decimal system there, right? And so temp 3, 255, temp 4, 255, temp 5, 9. Okay, I'm going to go ahead and get rid of that, and just leave you with some quick final thought there. So the long wrapper class provides you with the tools to easily convert between objects and primitive types. That concludes this tutorial. Thanks for watching.